Mercedes-Benz stands as a towering monument in the history of human mobility, not merely as a maker of luxury cars, but as the very crucible in which the automobile was forged. Its roots reach back to the late 19th century, a period of furious technical experimentation, when visionary engineers sought to replace the horse with a self-propelled carriage. This story is both intimate and epic. Intimate because it begins with a handful of mechanics tinkering in small workshops, and epic because their inventions rearranged the geography of industry, travel, and daily life across the globe. In the following account, we will travel through more than a century of engineering triumphs and crises, of aesthetic revolutions and brutal wars, of commercial strategies and technical breakthroughs. We will meet the minds who conceived the first motorized vehicles, discover how early experiments became production realities, and see how a brand defined by a distinctive three-pointed star came to symbolize excellence in mobility on land, at sea, and in the air. As you follow this narrative, imagine the creak of wooden wheels giving way to the hum of internal combustion engines. Imagine ordinary people astonished by the first vehicles that could carry them beyond the radius of a horse's endurance. And imagine the relentless push of engineers, factory hands, and entrepreneurs who transformed a fragile prototype into an industry that shaped the modern world. The canonical date of the modern automobile is 1886, when Carl Benz received a patent for his vehicle powered by a gas engine. To appreciate why this patent matters, we must picture the world of the 1880s, a Europe still dominated by horses, carriages, and railways. A world in which the notion of a self-contained motor vehicle was an audacious leap. Carl Benz, a German mechanical engineer trained in the tradition of precision and experiment, combined several disparate technologies: a compact internal combustion engine, a light tubular chassis, and a transmission system into a single drivable machine. The motor wagon had a rear-mounted single-cylinder engine, carburation peculiarities, a belt-driven transmission, and peculiar steering. It was fragile and experimental, yet it proved a crucial principle. A properly designed engine, integrated into a purpose-built chassis, could propel a vehicle reliably under its own power. The motor wagon's first public drives were halting and anecdotal, but a bold act by his wife, Bertha Benz, converted technical curiosity into a cultural event. In 1888, she undertook the first long-distance automobile journey, roughly 100 kilometers, to visit relatives. The trip created an immediate press sensation. Bertha's ingenuity in repairing the vehicle en route, her purchases of fuel and tools, and the vivid stories that spread across newspaper pages helped persuade a skeptical public that the automobile was not a mere laboratory toy, but a practical mode of transport. Beyond the romance of the motor wagon, Carl Benz's work codified design choices, engine placement, chassis strength, and attention to weight that would inform vehicle engineering for decades. His patents, manufacturing experiments, and early production runs laid an infrastructural and intellectual foundation for other pioneers who were simultaneously experimenting across Europe and North America. The motor wagon also catalyzed a wider industrial conversation about mobility. Inventors, municipal planners, and early entrepreneurs began to imagine roads, fueling points, and maintenance services tailored to this new machine. Small workshops gradually evolved into the first automotive garages, and a nascent aftermarket for parts and servicing emerged. In this way, Benz's work sowed seeds beyond the metal workbench. It reshaped local economies and encouraged the formation of new professions. While Benz concentrated on a fully integrated vehicle, Gottlieb Daimler and his chief engineer Wilhelm Maybach pursued a complementary path: lightweight, high-speed engines suitable for many applications. Daimler's laboratory experiments emphasized compactness and high rotation speeds, producing engines that could be mounted on carriages, boats, and stationary machines. This engine-first approach created flexibility and allowed designers to adapt power plants to multiple uses. The technical debate of the era, integrate everything like Benz or focus on engines like Daimler, proved fruitful for the industry as a whole. Daimler's engines, refined by Maybach's design sensibility, were characterized by better cooling, higher rev capability, and lighter construction. These features helped accelerate the early commercialization of motor vehicles by enabling smaller, faster, and more reliable chassis. By the turn of the century, a new marketing identity crystallized when Emil Jelinek, an enterprising businessman, insisted that high-performance DMG cars bear his daughter's name, Mercedes. The 1901 Mercedes 35 HP embodied modern automotive thinking, a low center of gravity, a long wheelbase, and a stiff chassis tuned for speed. It moved the conversation about what a car could be and what automotive design language might favor going forward. Daimler and Maybach's engines were not simply technical curiosities. They were pragmatic tools that accelerated industrial diversification. By emphasizing compactness and higher RPMs, their engines could be mated to lighter frames, enabling vehicles that were faster and more maneuverable. These qualities were crucial as automobiles began to escape their status as novelty items and enter practical service for commerce and transport. Further, the engineering ethos of Daimler-Maybach, which prized modularity and adaptability, proved influential for later mass production techniques. From the earliest days, racing served as both laboratory and spectacle. Speed contests and reliability trials forced engineers to refine engines, brakes, and suspensions under harsh conditions. Mercedes and Benz both raced. Success on the track translated into prestige and sales in showrooms. The harsh conditions of endurance events exposed design weaknesses quickly, accelerating iterative development cycles. Races taught engineers to balance power with durability and to design systems that could tolerate real-world abuse rather than ideal lab conditions. Competition between firms, the cross-pollination of ideas, and the emergence of specialized suppliers created a dense technological ecosystem. Innovations such as multi-cylinder engines, magneto-ignition systems, improved carburetors, and better metallurgy gradually evolved into standardized practices. Meanwhile, the industrialization of component supply meant that manufacturers could scale production with greater reliability. Engineers learned to translate track-derived technologies into roadworthy features and to design cars that could be produced repeatedly with predictable tolerances. This era also witnessed the professionalization of automotive manufacturing. Factories grew larger, workforce training became systematic, and the language of tolerances, gauges, and inspection systems became common currency among engineers and foremen. Continuous incremental improvements set in motion the long-term trajectory that would allow a company born from hand-built prototypes to transform into an industrial colossus. After World War I, the European automotive industry faced severe economic dislocations. Emblems of empire and pre-war prosperity had been shattered. Currency instability and supply shortages made single-company survival more difficult. In 1926, a decisive corporate consolidation took place. Daimler Motorengesellschaft (DMG) merged with Benz and CI, forming Daimler-Benz AG, the corporate ancestor of modern Mercedes-Benz. The famously simple three-pointed star, originally used by the Daimler family to symbolize mobility on land, sea, and air, became the central emblem. The merger unified design philosophies and manufacturing capabilities. Resources consolidated, research labs combined, and a coherent marketing voice emerged. The new company could invest in larger production runs, in more ambitious engineering projects, and in a brand identity that blended sporting prowess with stately luxury. Technically, the merger accelerated the diffusion of advanced engine technologies, chassis engineering, and safety features, setting the stage for expansion into new markets and the creation of vehicles that appealed to both elites and ascending middle classes. Through the late 1920s and into the 1930s, Mercedes-Benz cars populated prestigious races and exhibition halls, cementing a reputation for engineering excellence. The 1930s were an era of paradox for Mercedes-Benz. Bold technical innovation occurred alongside increasing political pressures and militarization in Germany. During this decade, Mercedes produced some of its most iconic pre-war cars, including high-performance models that dominated endurance and Grand Prix racing. Advanced superchargers, improved suspensions, and aerodynamic experimentation marked the period's engineering agenda. Designers explored streamlined bodywork to reduce drag, engineers advanced forced induction systems, and the interplay between racing research and road car technology intensified. Simultaneously, the company engaged in contracts that supported national priorities. Factory capacity was adapted for military production, and engineers were tasked with generating vehicles for a state increasingly oriented toward war. Yet the technical breakthroughs achieved during peacetime had lasting influence. Aerodynamic design principles, chassis rigidity concepts, and the pursuit of high power-to-weight ratios would inform post-war design philosophies. The 1930s also saw Mercedes-Benz exploring regular production models that could appeal to affluent drivers while simultaneously investing in aerodynamic research. Engineers experimented with streamlined bodies and wind tunnel-inspired forms that would reduce drag and permit higher speeds with smaller engines. These aerodynamic experiments, even when limited to prototype or racing contexts, contributed to a deeper understanding of efficiency that would reappear in post-war design. By the close of the 1930s, Mercedes-Benz was not only a German icon, but also a respected name beyond national borders. Its technical expertise, combined with a cultivated image of craftsmanship, gave the brand a unique appeal, one that would survive the catastrophe of the coming war and be reimagined in its aftermath. World War II inflicted sweeping destruction across Germany and its industrial base. Mercedes-Benz facilities suffered damage, supply chains dissolved, and the company's leadership had to navigate the moral and practical complexities of a country at war. After 1945, rebuilding became the overriding objective. Factories were shuttered or repurposed, and countless skilled workers had been lost or dispersed. The immediate post-war years required not only the physical reconstruction of plants, but the reassembly of supplier networks and retraining of a workforce in peacetime production. The company's recovery began with pragmatic models designed for a market of modest means. The 170 volts, reintroduced after the war, functioned as a versatile workhorse. Taxis, light commercial vehicles, and family transport. It represented a practical first step in rebuilding the production lines, rehiring skilled workers, and restoring supplier relationships. For the company's engineers and managers, the immediate goal was survival and gradual restoration, not grandiose innovation. Yet the seeds of a renaissance were planted during these years. The rebuilding process forced Mercedes engineers to focus on repairability, parts commonality, and production economy. Lessons learned in scarcity would later feed into more efficient practices, and the steady elevation of quality that became a Mercedes hallmark in the decades ahead. The post-war period also produced a careful repositioning of the brand. While earlier decades had emphasized speed and engineering spectacle, the company now foregrounded reliability, service networks, and incremental innovation, building trust with consumers who had endured years of deprivation and uncertainty. The 1950s saw Mercedes reassert itself as a global leader of car engineering and design. The 300 SL, introduced in 1954 with its iconic gull-wing doors and direct fuel injection, dazzled enthusiasts and collectors, while the company simultaneously invested in research into safety, an area in which it would eventually claim leadership. The 300 SL was not merely stylistic theater, it was a technological showcase demonstrating the company's competence in materials, chassis stiffness, and engine performance. A defining feature of Mercedes' strategy was to marry performance with occupant protection. The company sponsored crash research, structural testing, and the development of technologies such as rigid passenger cells and deformation crumple zones. Over time, these safety investments would become not only moral imperatives, but also commercial differentiators, reinforcing Mercedes' image as a maker of uncompromised engineering. In subsequent decades, innovations like anti-lock braking systems, airbags, electronic stability control, and sophisticated driver assistance would trace conceptual lineages back to this period of prioritized research. During this era, Mercedes also expanded its global sales networks and manufacturing footprints. The brand diversified its lineup, introduced purpose-built models for numerous market niches, and deepened its position across continents. The combination of glamour cars like the 300 SL and sober, reliable saloons created a brand ecosystem that nurtured both aspiration and practical demand. From the 1970s onwards, Mercedes navigated waves of change, energy crises, the rise of Japanese competition, and the increasing complexity of automotive electronics. The company responded by doubling down on engineering excellence, improving diesel technology, refining automatic transmissions, and integrating electronic control systems that would eventually underpin modern stability control and emission management. Diesel engines, in particular, became a significant competitive advantage in Europe and other markets that valued fuel economy and durability. Mercedes developed rugged, efficient diesel powertrains that served taxis, commercial fleets, and private owners for decades. The strategy also involved brand segmentation. High-end offerings like Maybach, later revived, targeted the ultra-luxury segment, while the Mercedes-Benz core brand broadened to include compact executive cars, SUVs, and high-performance AMG variants. The G-Class, originally a military project, morphed into a coveted status symbol. The S-Class consistently functioned as a spec sheet for industry-first technologies, from airbags to radar cruise control to sophisticated infotainment and safety suites. By the turn of the century, Mercedes had developed a diversified portfolio that allowed it to compete on multiple fronts: luxury, performance, commercial vehicles, and emerging environmental technology. Global manufacturing footprints expanded, joint ventures proliferated, and Mercedes adapted vehicles to local tastes while retaining a strong engineering identity anchored in German technical culture. Facing an epochal shift towards sustainability and digitalization, Mercedes entered the 21st century with renewed investment in electrified powertrains, hydrogen research, and digital connectivity. The 2010s saw hybrid and plug-in variants proliferate, while concept cars and production models under the EQ sub-brand signaled a clear commitment to electric luxury mobility. The EQ label represented a design language and a technological toolkit oriented around battery architecture, thermal management, and software integration, a conscious attempt to translate Mercedes' luxury heritage into a new energy paradigm. Simultaneously, Mercedes invested heavily in autonomous driving research, sensor fusion, and software stacks capable of over-the-air updates. This software approach changed the company's internal dynamics. Partnerships with tech firms, acquisitions of startups, and the creation of internal software platforms shifted resources and talent. Challenges remained: battery supply chains, semiconductor shortages, and the complex task of remaking factories previously optimized for internal combustion engines, but Mercedes' commitment to a multi-path future reflected both prudence and ambition. In the 2010s and 2020s, Mercedes pursued multiple parallel strategies, establishing the EQ sub-brand for battery electric vehicles, advancing hydrogen fuel cell demonstrators, and integrating software-defined functionality into cars. This software approach changed the company's internal dynamics. Partnerships with tech firms, acquisitions of startups, and the creation of internal software platforms shifted resources and talent. Today, the company faces an uncertain but opportunity-rich landscape. Legacy production systems must adapt to new electric platforms, customer expectations evolve rapidly, and competition from new entrants is intense. Yet the three-pointed star retains symbolic force, a reminder of a lineage that helped invent the automobile and now strives to shape its next century. Mercedes-Benz's story is, in many ways, the archetypal industrial saga of the modern era. It entwines individual inventors and corporate managers, racers and factory workers, designers and policymakers. Its legacy encompasses breathtaking aesthetic design, engineering advances that improved safety and performance worldwide, and manufacturing systems that influenced entire industries. As the world confronts climate constraints, urbanization, and shifting mobility needs, Mercedes-Benz faces a moment of reinvention comparable to the transition from steam to internal combustion. Its choices, whether to accelerate electrification, to pursue hydrogen at scale, or to prioritize autonomous mobility, will matter not only for shareholders, but for millions of drivers and the global environment. The three-pointed star is more than a logo. It is a living history, a promise of mobility across environments, and an invitation to imagine the next chapter. In understanding Mercedes-Benz, we understand a large part of the modern world's industrial and cultural history.